Hello again everyone and welcome back to my workshop. This episode is brought to you by my sponsor, a double espresso and a chocolate biscuit. A question was asked on a Facebook group about adding a little scale addition to Mustang style wheel doors, whereby when the ignition for the engine was switched off from the radio, the main wheel doors would open and hang down, and when the ignition was switched on, the doors would close up again. And the reason for this is, if you're familiar with the full-size Mustang, you'll know that the doors are driven by a hydraulic system, which is driven from a pump run by the engine. And when the engine is switched off, the pressure in the hydraulic system slowly ebbs away, and after some time the doors will start to open on their own due to the loss of pressure, and eventually they'll hang down. And when they start the engine up, after just a few seconds, hydraulic pressure rises and the doors will magically close up by themselves. So our user wanted to use the ignition switch on the transmitter to make the doors simulate this for a bit of extra realism. How do we go about it? Because obviously he couldn't get anything to work with the sequencer. So we've got a servo here showing the position of the door. I'm going to use the retract switch running the sequencer, and we'll get round to using this as the ignition switch. Now, with Jeti, as ever, and indeed with any sophisticated radio system, there are several ways of doing this, and some of the choices are really going to depend on your own personal preference. So I'll go through basically the way I would do it, but you can vary it with some of your own personal preferences, perhaps. So if I switch the gear up, the door will open, stay open for a short time, and then close. And I switch the gear down, again the door opens, and then the door closes. Let's have a look at what we have to do to get the extra switch to work. If we go into the advanced properties, into the sequencer, you can see first of all I'm not trying to do any of the servo slowing in the sequencer. As you would have noticed, the servo is running at full speed, and we'll come to that at the end. So what we're doing here is just the 0.1 of a second difference between the low and the high points to run it. Let's look at the advanced, and this is the very important thing. Do not overwrite the channel. If you're using individual servos on each door, then you'd have to write a sequencer for each servo if you're going to overwrite the channel, and we'd like to avoid that. You can use overwrite channel if you're using one servo to move an air valve, but why would you still not do that with this one? Well, it's because once you use a sequencer to overwrite the channel, you just can't get anything else to influence it. Flight modes won't influence it, and mixing won't influence it. So don't overwrite the channel in this case. Say OK to that. So that's our sequencer setup. How then do we get the sequencing to work? Well, we go to Model, Function Assignment, create a door function, and very importantly, we've assigned the sequencer as the control for it. If you're not sure how to do that, I'll go in, clear it out. So we say plus, scroll down, choose the sequencer. It was sequencer 1. There we are. And now you can have any number of door servos, will all be run from that without having to make a separate sequencer for each one. So we say OK to that, and in your servo assignment we have as many servos as we require assigned to door, and they will all get that same sequence. You can, of course, in servo setup adjust the end points of each servo individually. Okay. And now we come to a couple of the choices. How are we going to implement this ignition switch to make the servo go to its down position? Well, we could do it through flight modes, or we could do it through mixing. I think I would probably choose a flight mode myself. And the reason is, if you need to do ground testing, it's easier to overwrite the flight mode that's pushed the door open, and then you can happily raise and lower the gear to your heart's content, checking all your sequencing, checking your servo setups, etc. Whereas if you've used mixing and your ignition switch is in the ignition off position, then it's going to mess up the sequencing, and you would have to put your ignition switch to the on position in order to do all your testing, which could be fine because you could of course unplug the ignition battery. So I'm going to show you both methods. So first of all, we'll look at the flight mode version. So flight mode, we've created a flight mode called ground, and I've made sure it's below my flap flight modes, so I can use those to overrule it if I need to do ground testing. So the battery could be connected to the ignition switch would be in the off position, but all I would need to do is go to flap 1 or flap 2 flight modes, and I've got full control of testing the system up and down again. So what do? We go here, and select our switch for it. There we are, ignition off, say OK, and now we get in the ground flight mode would be on. We say OK to that. We come to the function curves, go to the door, change it to separate, and then have a look at the function curves. I'll switch off the ground flight mode, i.e. ignition is on, and see that we still keep the standard curve for all our flight modes except for the ground flight mode. We've changed it to a constant curve, and we've brought it down to the value we need to get the door fully open. So we say OK to that. Then now we can see that our normal flight modes have no effect, the flap flight modes. But if we change to the ground flight mode, default goes to ground, the door goes to the open position. In other words, we've switched off the ignition and the door has opened. Next time we're ready to fly, we switch the ignition on and the door comes back up. So let's take that out for a second and show you the mixing method of doing it. Okay, so we'll just prove that no longer works. Free mixes, there's 2 mixers, both of them from door to door. Let's have a look at this one. The switch you'd set would be your ignition switch, so the switch on, and the master value of the first one will be minus 100%. That basically that zeroes out whatever the sequencer is trying to do, and it would send the servo to the mid position. If I switch it on, you'll see it go here to its mid position. Yep. And the next mixer, same switch again. So switch down, ignition off, switch goes on, and we'll set the master value here to whatever value you want the door to go to. We'll go to minus 100, but you could say minus 90 if you were using a global command here. If you needed both servos just to go in the same amount, might just be easier to go minus 100 or plus 100 as required, and then use the servo setup to get each individual door just perfect. Say OK to that, and now you can see it does the same thing with the ignition switch. So I've got my sequencing with the gear up, sequence the gear down, we've landed, taxied back in, ignition off, and the door will open. Okay, so far so good. The problem here comes that if you're wanting to do testing on the ground, you've got the ignition off, and now your switch works in reverse. So instead of the door up, down, up, it's going down, up, down, which could get confusing. So that's the very slight reason I would prefer the flight mode way, but you could put your ignition switch back on and simply disconnect the ignition battery, and away you go. If you don't like messing about with flight modes, there's the mixer method. Finally, we want to slow the servos. Remember I said don't use a gradient in the sequencer to give you servo slowing. We'll do it all at the individual servo level. And the reason we don't want to do the gradient in the sequencer to give you servo slowing is that it then wouldn't have any effect when we switch the ignition off and on. The servo would then run at full speed. So you then have to do slowing in your flight modes, and you may not get the slowing back to the default mode that you wanted when you come out of the flat modes. If you're using mixing, then you'd have to set up delays in the mixer. Well, it's just as easy to go into the individual servo and set them. And we'll choose 1 second for each way. Oops. And now, there, we have servo slowing, so the doors move at a nice speed, and it works to when you switch the ignition off and the door falls open, and when you switch the ignition on, the door rises. So there you are. That's how I do it with some of the options in it. There could be other ways, or you may prefer to move some of the little bits about, but here at least is a way that works.